Hello everyone. Our topic for today's project is movie ticket reservation system. We are team 7 and we include the members like Kumar Mehul, Mansi Upadhyay, Tanuj Marma and myself Kritik Kanakya. Our contents for today's presentation are objective, architecture diagram, entity relationship diagram, graph model, database implementation and visualization. The objective of our project was to create a database system to store the information of the data sets. We used the Python ETL to pre-process the generated data. We then implemented ongoing data refresh for the database, and we used visualization to see the trend of the system in Tableau. This is our architecture diagram. We generated Mockaroo. We generated data from Mockaroo, and we had some discrepancies in the data like null values and all. We pre-processed that in Python and we stored the collections in the ArangoDB. We then use a data refresh, ongoing data refresh implementation code and stored the updated CSV files into the Arango. We performed data analysis on that file using EQL queries. And finally, we visualize the data in Tableau. Next, Kumar Mehul will take further.
So for our project, we have 5 collections in total. We have customer, reservation, showtime, theater, and movie. Customer and reservation are connected. Reservation is connected to showtime, and showtime in turn is connected to movie and theater. And movie is also connected to theater. Next slide, please. So this is a graph model for the project. So we have 5 collections. So they represent 5 nodes. And for those 5 nodes, we have created 5 edge files. So between customer and reservation, there is custres. For reservation, showtime, there is ratio, and so on. We have implemented these many edge files to improve the processing time for the queries we are using in our database. So now Tanuj will explain the data implementation part.
Hello everyone. So now I'll be talking about the data implementation on our ongoing data refresh. As Kritik told us that we had many discrepancies on our data from when we imported it from Mockaroo. So here you can see in our Python script that we have dropped the duplicates and we have dropped any null values. So this is our initial ETL phase. So we take the data from Mockaroo, we run it through our Python script, and then we get clean data. So now we then upload this clean data this clean data is now ready to be imported into ArangoDB. So this is after we are done cleaning the collections. These are the 5 collections which you can see in our UI. After that, we have used 5 different types of query to create 5 different edges in our database. So this is how the data in the edge looks like, and this is the query which we have used to create our edges. Similarly, we have created 5 edges, and this is how our complete database looks like. So we have 5 collections in total, and we have 5 edge files in total. Now going on to the ongoing data refresh. So we have used again a Python script to automate our data refresh, and we have used Watchdog library of Python to monitor the JSON files. So all the collection files which we had, they were all in JSON format. So the path at which they were stored, which is this users downloads ADBMS project JSON. So whenever any JSON file is updated in this particular path, the code will automatically collect the information that, as we can see here, collection updated theater, and it will automatically reflect into the ArangoDB. Now I'm going to show a live demonstration for this. So this is our Arango web UI. So we'll take one customer. Suppose this is our customer information of customer ID 1. We can see that the ID is 1, name is Tanuj. These are all the emails. So the data refresh code which I had shown earlier. So I'll just simply run this code. In this, I am checking the files using event handler. So we can see that our code is running. So this is our JSON file which is stored in that particular path. So for example, I just changed the name from Tanuj to Tanuj Verma, and I save it. As soon as I save it, you can see that the collection is updated here, and it tells us the name of the collections which was updated. Now we go back to our original web UI. Here you can see the name is Tanuj here right now. As soon as we refresh, we can see that the Tanuj Verma is updated here. So this is how we have implemented our ongoing data refresh. So for our current data set, we have used Mockeru. So even if when live data is coming, so to the same code, we just have to automate it using cron job. So it will keep on checking on whatever schedule we want, and it will keep on updating our database. So it will work for both if you are taking your data from a data set, or you are creating a pipeline and you are importing live data. Now we'll go back to our PPT again. So this was the ongoing data refresh which I was talking about. Now Mansi will talk us through data visualizations. Mansi, can you please can you hear us?
Am I audible now?
Yes, you are.
So coming on to the data visualization, the data source of these visualization is being imported using a web connector, and the data is being pulled directly from a database rather than a CSV or a JSON file. So next slide, Tanuj. Yeah, so here we have the query, and which gives us the following output and the visualization. So the first visualization focuses on the number of theaters screening each movie. So this visualization displays each movie with the number of theaters screening that movie. So for example, searching for Bobby Fischer has a count of 7, indicating that the movie is currently being shown in 7 different theaters. So this visualization is useful for identifying trends in movie popularity. Next slide. Yeah. So the next visualization is movies with counts of showtime. So it shows the popularity of each movie among customers by displaying the number of showtimes for each movie. So for example, Human Capital has 4 showtimes, indicating that it is more popular than Country, which has only 1 showtime. So this visualization could guide decisions on adding more showtimes for popular movies. Next. Yeah. So coming on to the third one, which is the customer's movie watch list and duration. So which visualizes, displays the movie watched by each customers and the duration of each movie. So here, for example, Tanuj Verma has seen Zoom with a duration of 2.930, Hill with a duration of 2.670, and 40 Guns with 2.840. So this visualization observes which customer watches more movies so that the customer can get offers and discounts. The fourth visualization is focused on customers with reservation counts. So this visualization displays the number of reservations made by each customer. So for instance, Tanuj Verma has made 4 reservations, while Eddie Raspel has made 0 reservations. And coming on toward the geolocation visualization display. So this displays the number of theaters in each US states, with Texas having 4 theaters, Massachusetts having 2, Florida having 4, and so on. Now coming on to our customer dashboard. So this gives a clarity on how customers are interacting with the movie service, what types of movies are the most popular ones, and how frequently customers are making reservations. So this helps the service to understand customer behavior. Next. Yeah. So the next dashboard is theater and genre dashboard. So it includes the number of theaters in each location, as well as the summary of different movie genres and their associated reservation counts, movie counts, and average rating. This visualization is useful for identifying patterns in movie popularity across different locations and genres. Thank you. We are open for questions.
If anyone has any questions, they can ask.
Yeah, we have a question.
Yeah.
Could you switch back your architecture diagram?
One second.
So your data pre-processing and refresh Jupyter Notebook, right?
Yes,
So
yes.
I remember you mentioning that it's not it's so currently your notebook it's running locally, right?
So we were running it locally to show the live demonstration. So we can
Okay.
just run the same script in a cron job. So as per
Okay.
our schedule, whenever we want, we can run it as per our convenience.
Yeah, my question was around that only. Like, is there any blocker from running it in a cron job, or was it just a choice of preference?
It was just a choice of preference. So I use Mac, so cron jobs are easy to handle in Mac. For Windows, we can use another process.
Okay, cool, makes sense. Thank you.
Yeah. No problem. Thank you.
Tanuj, I have a question.
Yeah.
So all of your files are like one level documents, right? So are they nested?
No, they're not nested.
Okay.
We did use nested files.
Okay. So is there any, advantage using the document DB for such sources like instead of, do we have any advantage choosing document DB instead of relational DB over here?
Yeah, so when we are using document DB, so all the personal information, for suppose I am a customer, so I have 5 attributes: name, phone, email, address, whatever are my personal attributes, and there is a separate attribute which separate collection which is named movie. So movie has its own parameters. So we use just the graph to connect these two collections. So we don't need to write complex query that we have to match this key and that key. We'll just simply use a node. Sorry, my bad. We'll just simply use a graph to connect these two databases. So it makes our querying very easy. As it depends upon our data model. So for this movie part, we have suppose we have customer and suppose we have movies. So if we are using a relational database, we can store the whole data in one database. So while we will be querying it, so we'll have to use different keys to connect these two. But when we are using a graph model, we can just simply mention the which graph which node or which graph we want to use, and it will directly query the data from those two collections and give it to us. So in that sense, it is way much easier and efficient.
Sounds good. Yeah, I really liked your presentation and project. Thank you, Tanuj.
Thank you so much. Thank you so much. Any other questions?